So I got a super quick update on the vacuum project. I made a slight modification. Per that last blog post, I'm still using a battery now, still using the boost converter to go from 3.7 to 12 volts for the light bar, but now we're using the 16 and or 26 volts as a signal for the boost converter to turn on and off. So now, we've got what you'd expect. So we've got 3.7 volts here and 16 or maybe 27 volts here. That's not that great. So what I've got is a voltage divider here on that input enable pin. So we've got 1K on one side and 10K on the other. So it's an 11 to 1 voltage divider, which at 16 volts hits the enable pin with 1.45 volts, which is just enough to turn this guy on. Now at 26 volts, it'll still be below the 3.7 on the input, so we're still safe. Now, unfortunately, even besides the lackluster fit and finish of this, it's not quite done and dusted yet. See, the problem is, this is a boost converter. It's a regular, normal boost topology, which unfortunately means there's a switch in here that connects this inductor to ground and then lets go of that to spike the output voltage up higher than the input voltage. The disadvantage of that topology is when this converter is disabled, unfortunately, that just turns the switch off and connects input to output straight through that inductor. So in this case where it's off, unfortunately there's still 3.7 volts on here, and there's actually a little bit of current flowing through this guy, draining the batteries. Now it's really not a lot, and even though this clamp meter can resolve milliamps, it's going to be really difficult to detect the potentially single-digit milliamps that are flowing here. And as you can see, I'm trying to zero this thing, can't get much off of it. Well, sure enough, we see a little negative current. Maybe 10 milliamps? I don't know. Tough to say. Maybe more like 6 milliamps. Maybe more like less than that. But it'll still drain this battery eventually. Now, if I had to guess, I'd probably say I won't get around to this. But the next step for this is, if we replace this boost converter with a different topology, there are plenty of options to go from a lower voltage to a higher voltage that actually have switches that can completely disable or disconnect the input from the output, and therefore no current or only a little bit of, parasitic drain will pass through, and this battery won't die nearly as quickly. Now, an obvious next step after that is stop book taping this stuff to the vacuum head. So if I get around to replacing this converter, I'll probably also toss all of this into a nice 3D printed enclosure at that point too. Probably not before then, if I'm honest. So I guess, yeah, we'll see how long it takes me to get around to that stuff. See you next time.